This is section 1.1, function and function notation. In this video, we're going to go through problems 11 and 25 in your book, and these are examples where it's asking us to determine whether these relations represent functions. So if you remember, in order for a relation to be a function, it must have a one-to-one relationship. For every one value that we plug in for our x, we have to get exactly only one output value for our y. So the way we solve these types of problems is we can plug in test points for our x and look at our equation and see how many output values for y we get. If we get only one, then it's a function. If we get more than one possible values for our y, then that means that our relation is not a function. Okay, so starting with number 11, what I'm going to do first is solve for my y, my output, and I get this equation. And next, I'm just going to plug in test values for my x and see what happens. So let's say I plug in -1 into my equation. I'll get 14 minus 3 times -1 squared. 14 minus 3 will just give me 11. And I think, is there any other possible answer I could have gotten? No. When I plug in -1, the only possible thing that could happen is that I get 11. And I can try another value. Let's say 0. I get 14 minus 0. That can only equal 14. Let's try another one, +1. When I plug that in, I'll get 14 minus 3, which again is 11. And again, that's the only possible output value I could get when I plug in my x value. So I see that I have only one output for y for every input. So this means that this is a function. And what this might look like on a graph is, let's say at -1, I have 11. At 0, I have 14 for my y. And at 1, I have +11. And thinking back to that vertical line test, we see that this function here passes the vertical line test. It is a function. Now don't let this same y output value trip you up. We can have the same y output value as many times as we want, just as long as for each x value, we only have that one y output value. All right, moving on to number 25, we're going to do the same thing. First, let's solve for our y. Get y is equal to square root of x squared. Don't simplify this because we want to keep the function in as same as terms as what they gave it to us in. All right, so now plugging in values for x. Let's say I plug in x equals 2. When I plug that in, I'll get the square root of 4. And square root of 4 can be either +2 or -2. Both of these values, when squared, will get me back to +4. Okay, so I can plug in 3, and I'll get the same thing. I'll get rad 9, which again simplifies down into both +3 and -3. Since for each input value of x, I got more than one output value for y, this means that this is not a function. And what this might look like on a graph is, here at x equals 2, I have both +2 and -2. Here at x equals 3, I have both +3 and -3. And this will continue on for every x value that I plug in. And I see, going back to my vertical line test, this does not pass that test. So that's it for this video. You can just plug in test points into your function and see whether you get one output value or more than one output value to determine whether this is a function. The concepts covered in this video are true no matter what pre-cal class you're in, but in case you're interested, all the problems referenced in this book came from this lovely book right here. Remember that if you're a Baylor student, we offer free tutoring on the first floor of Sid Rich. You can either make an appointment or drop in whenever you're available to get tutoring in pre-cal, calculus, and a bunch of other subjects as well. Feel free to visit our website for more information.